And I always like to give the example that it took me learning Cypher in order to understand what the SQL halving and group by clause was trying to do.
Hello, welcome back, everyone. Welcome back to the next episode of simplyblock's Cloud Commute podcast. This week, I have another incredible guest. I know I say that every single time. It's just true. They're all incredible, and you know that, right? Hello, Jennifer.
Hi.
Maybe just give us a quick introduction, very quick.
Sure. My name is Jennifer Reif. I'm a developer advocate at Neo4j. Focusing on Java technologies and its ecosystem. So I cover the gamut on, yes, anything, almost anything Java. So I've worked at Neo4j for the since 2018. Let me put it that way. It's been a little bit. And I do some show up at some conferences, as well as write blog posts, do videos, a little bit of Neo4j's podcast, graphstuff.fm, and code demo projects and presentations and the whole 9 yards. So I am happy to be here to talk to Christoph and chat a little bit about technology and Neo4j and so on. So
awesome. I think you're actually the first person who ever said Christoph on the stream. So now people know how I'm really called. Chris is fine. It's so much easier for the rest of the world. But you said you're working for Neo4j. Obviously, I know what Neo4j is, but maybe just give the others a quick introduction. What is cool about it? What is it? And
sure.
You know the spiel.
Neo4j is a graph database. And I guess to start off, it just like any other database, it stores data. A lot of people will say, oh, is it a layer on top of another type of database? No, it actually is a storage system. You store the data, writes to disk, and the whole gamut there. But it stores data differently than rows, tables, documents, so on. It stores data as entities and then relationships between them. So you actually write the relationships to the database. That makes it really easy to read those relationships back. So anything where you have a lot of complex relationships or a lot of relationships and a lot of hops through different types of data, a graph database is going to be optimized and more performant for those types of queries.
Right.
So lots of things like networks or social network structures, supply chains where you have a lot of depth and hopping around, even just fraud detection. And there's a variety of different use cases, software dependencies, lots of other things. So I've seen it used for kind of hit or miss, just kind of random things that it's like, oh, I would have never thought to use a graph for that, but it works really, really well for any type of case where you have a lot of relationships and a lot of connections in your data.
So that's interesting. I think the weirdest thing that I've built and at the same time the most efficient thing was actually a permission system. With inheritance and roles and permissions and inheritance between the different roles, because you're basically can make a single like Cypher request and say, give me every permission that is somehow in the hierarchy or in the inheritance graph, and remove everything that might be overridden as what is the term? Disallowed. Denied. That's it.
Yeah, blocked or
disallowed.
denied.
I like that. so that was really nice, and it was so much easier than doing like a graph or like a table tree kind of recursive SQL lookup on a relational database. I think I still have the code somewhere.
That would be really cool. You should publish that somewhere or like highlight it somewhere.
I can try to find it and well, let's see, but maybe I hand it to you.
Yeah, I've seen some genealogy or like family tree type of scenarios.
And just a couple of lines. It was like I think 3 types and 4 relationships or something, and you're done. It was brilliant.
Yeah.
Anyway, so you said it's a graph database, and you gave a couple of ideas what a graph database could be used for. And well, I hinted on why graph databases might be easier, right? So especially when you do like topology or relate any kind of relation lookups. You said social networks, parent family trees, anything like that, where you have relations, especially like when you look at European history, like between the different kings families, and there's a lot of connections and relations between almost all families.
Yeah.
So if you're trying to understand or to look into those kinds of things, graphs are super helpful and much easier. But what would you say is like the biggest difference from a typical database, for example, like a relational database, except you said Neo4j or graph database stored slightly different?
Yeah, I'm slightly biased, so I have a long list of things I love a graph database
All right.
for over other things. But if I had to narrow it down to just one, the thing that I find most impactful is that you don't need to have expert knowledge about the data model in order to pull valuable data from a graph database.
Mm-hmm.
So you had mentioned, you have a few different types of relationships. You don't have to know what those relationships are going into the graph database. You say, hey, look, I know I have these entities, find all the ways they're connected, and remove the connections that are, the denials or the denied or blocked or whatever credentials, or
Right.
access paths. And you can filter those types of relationships out. And with a relational database, sure, that's probably possible, but the amount of work and the amount of knowledge you have to have up front, first of the data model, and second of SQL in order to handle those very complex filterings and like subqueries and so on, is a lot higher. That learning curve is a lot higher. So that's the thing that I love most about graph databases is the data model itself is, it's not required to know it upfront well, and then it's naturally very visual, so it's just easier to navigate and easier to just explore without having this massive learning curve up front to know the data.
I love that. I love that. Specifically, as far as I remember, Neo4j was involved into a lot of like analytical use cases towards things like the Panama Papers, right? As far as I remember, Panama Papers, like the whole network was basically put into Neo4j, and then the journalists started analyzing this massive graph, and all those companies worked together. And that is exactly what you said, right? You don't have to understand or have to know yet how those things are connected, or is it people, is it companies that somehow work together that make the relation. You figure that out while you're looking at the data and while you're looking at the graph and trying to understand what that means.
Yep. Yeah, my favorite thing is to just take a data set that looks interesting to me, dump it into Neo4j, and then just start querying and see what interesting things I find from it. And then that's what I end up focusing on and playing around with. Where I feel like a relational database, it's almost the opposite. You have to really kind of figure out and look at the data and the spreadsheets or whatever, data format you have, and figure out, okay, what does the structure look like? How can I make the connections from one hop to, the next table and so on. A graph is a little bit of the reverse there.
Yeah. Well, I'm not sure. Is that a general graph database thing, or is that very specific to Neo4j because you don't necessarily need a schema?
Yeah, I know there are some other graph databases that kind of have that schema optional, schema less, schema free, however you want to term it.
Right.
And so Neo4j is not the only one in that category, but I feel like just the length of time that Neo4j has been around, that we kind of have like a leg up on a lot of the other graph databases. So those that do provide that capability, it's just a really nice feature.
Right. Yeah. I'm asking because I think for relational databases, I mean, one of the critics or points that people always talked about, and the whole like NoSQL thing where it came from was like, you don't want the schema. You want this kind of schemaless. You have an optional schema, and if the schema can evolve over time, but with SQL database, or at least relational database, not necessarily SQL, but relational database, you have to come up with this, like, relational model up front and
Yeah.
define it. And I think that is where a lot of like the problems come when you have an unknown data set and a very complex data set. If it
Yeah.
evolves over time, it's probably fine. But when you get something, um, it's probably much more complicated.
Yeah.
So, as a developer, I mean, I'm coming from a relational world. So I'm a Postgres developer, but I understand I may need a graph database like Neo4j. So how would I get started with that?
Well, one of the best ways we have currently is our database as a service called Aura, Neo4j Aura. And we have free instances. So we have, different tiers, of course. We have a free tier and then kind of your paid tiers above that, depending on your needs
Right.
there. But the free tier is a really great place to start. There's lots of tools surrounding that free tier. So they have like a data importer tool where you can load up like PDFs or CSVs or some other different types of data. And it will kind of help you get that data into a graph. So you don't have to have that knowledge up front. And then you can kind of query or play around with our visualization tool called Bloom. And it kind of is a natural language query interface. So you don't have to know a lot of Cypher up front. Even the Cypher portion of it, there's guides that kind of walk you through. So it's just we try our best to have a very
Right.
low barrier to entry pathway there for people to learn.
I think you mentioned Cypher. The thing that makes Cypher from my perspective so much better than the other graph languages is that it actually looks like ASCII art.
Yeah.
It looks beautiful. You look at the query, and at some if you go a little bit deeper and use some of the more complex constructs, it's a little bit more complicated to understand if you don't know how it works. But like a standard graph query over multiple nodes and relationships, you look at that and it's an arrow telling you, oh, here's a node, here's relationship, and that's what I expect. And that is how many you can have between those. I just love it. Whoever came up with Cypher, thank you. Thank you for the love of God.
Yeah. It's a super approachable query language.
Yeah.
I feel like I had learned several years of SQL before I even knew about Cypher, and when I came over to the light side, if you will, at Neo4j, and started exploring Cypher, there were several things that it's like, why in the world isn't everybody using something like this? Because it's very easy to read, very easy to construct, at least kind of the general starting structures, right? There's way more complex things you can do with it. And there's still lots of things I look at it and go, okay, how do I do this pattern, construction and manipulation? Because patterns
Right.
are very complex. But yeah, just at the outset, it's a much more approachable language, I feel like, and has some really cool, fun things to do with it. And I always like to give the example that it took me learning Cypher in order to understand what the SQL having and group by clause was trying to do.
Right.
It was just way more apparent in Cypher than in SQL.
I agree. And I think, and that is where a graph database comes in general. As I said earlier, in SQL, when you have those like multi-hop relationships, you end up doing something like this weird recursive SQL, and it works, but it's never gonna be nice. It's
Yeah.
it's a recursive a common table expression with the union and a join, and I have to look it up every single time. I've used it so many times. I always get like 95% to where I want to be, and then it just doesn't work the way I expected, and I have to look it up. And I'm probably made some mistake on the join type or on the join class.
Yeah.
And with Neo4j, or in general with graph database and specifically Cypher, it is so much easier to model that stuff. Even when you use a merge or something, it's still way easier.
Yeah. And for those of you who are not familiar with Cypher or thinking that this is a Neo4j thing, first of all, we have Open Cypher, which is completely open source. We open sourced it, I believe, back in 2015. But just this year, Neo4j and several other graph database vendors all got together and came up with the ISO GQL standard, GQL standard, that was released, I think, like a month and a half ago now. And so there is an official graph query language standard now that Cypher has poured a lot into that as well. There's a lot of things that have come over from Cypher, as well as some other graph query languages too. Mm-hmm. So it will be an official, like, unified standard, of course, when everybody can kind of get to that.
An ISO standard.
Yep.
Wow. I did not expect that to see in my lifetime. That is incredible.
It's been several years in the making, yeah. And Neo4j and all the other graph database vendors have been hard at work getting that all together. But yeah, it all got approved and everything just recently.
So how does it work from a programming language perspective? I know that Neo4j has a lot of drivers. Obviously, it's not a SQL interface, so you need something different than, for example, in Java JDBC or in Go, the scan interface. But I think there's drivers for almost every language I've ever considered.
Yeah, we provide official drivers for like the bulk of your core languages. And then there's community drivers that are very well supported, very well maintained by partners or communities or so on for several other languages. And then we also do have like a JDBC driver and other things too, as well as integrations to major frameworks. So like our Spring Data Neo4j integration has been around forever. And several others as well. And of course, we have like the big Gen AI ones now, your LangChains, your Llama Index, and so on too. So basically anything you want to integrate with or around, Neo4j has some kind of connector or integration or driver or something to do with it.
All right, cool. You already mentioned Neo4j Aura. And as far as I know, we're a cloud podcast, but we're also a Kubernetes podcast. As far as I know, Neo4j Aura internally uses Kubernetes, right?
Yes, as far as I know, yep. Kubernetes.
As far as you know, okay.
Yep.
So we're probably on the same level of understanding.
Yeah, there may be some other things they do as well, but yes, we run Kubernetes, and we have a very good integration and partnership there.
Okay, so that means I can also use Neo4j on Kubernetes outside of Aura.
Yeah, the thing that at least I didn't realize until I started digging in just a little bit is running a database on Kubernetes is not a simple like spin up X database. There's a lot of because
if you don't care for persistence, yes.
Right. Kubernetes is very customized because typically you're dealing with enterprise systems and you need to mess or customize with individual components or pieces. So running Neo4j requires about 4 or 5 different components that technically run or would run separately on Kubernetes. And so if you've ever heard of Helm and Helm charts, that's the easiest way to, it basically just outlines, these are the services, the pieces that I need in order to run Neo4j, spin all these up together and manage them this way and replicate them this way. And so it's actually pretty easy to get up and running with the Neo4j provided, managed, supported Helm chart.
Interesting. So the reason I'm saying interesting is because everyone these days talks about Kubernetes operators, and we have the operator to set it up for you, and you say no, use the Helm chart. That is like it's so refreshing. I haven't heard that in a while. I think the reason is that operators give you a lot more like operational well, you can react at runtime to certain situations where it is the Helm chart is basically just the installation. I think that is the reason why a lot of people use or move towards the operator.
Okay.
But that's just my guess. Maybe it's just like cool to have an operator these days.
Could be, yeah. The latest thing.
Yeah. So let me see. We talked about developers. We talked about the programming languages. We know you can run it on Kubernetes. Make sure you have a persistent volume if you run a database. We talked about that.
Yep.
And if you need a persistent volume provider, I heard that simplyblock might have something for you. But there's a lot of others as well. Actually, just yesterday, or on the weekend, I started a small website where you can look for all the different CSI providers, basically the volume providers that it can be plugged into Kubernetes, everything that I know and found, and I split them by features, and you can search. So if you're in the search for a CSI provider, storageclass.info is probably what you want to look into. If you find something that is wrong, feel free to send a pull request. It's GitHub pages. Just like as a side note. Okay, because we're pretty much out of time. What do you think is the next big thing in cloud, in graph database, in databases in general, in AI? Feel free to name 2 or 3 things as well.
Yeah, well, I think AI is kind of the big thing right now, but I think we'll start seeing that not necessarily taper off, but we'll start seeing that integrate into kind of just our standard day-to-day, rather than that, I think, being the focus for everything. I think we'll kind of see, us not go back to, but kind of modify what was our workflow to integrate LLMs and Gen AI stuff into our day-to-day things. And so it will become just a piece of the deployment puzzle, or building puzzle, or application puzzle, whatever it is. And so I think that will kind of get standardized a little bit better. We'll kind of figure out where the super useful applications are, and the highly critical and impactful workflows that we need to use it. And so I think databases are going to be a huge component of that, whether it's graph or something else entirely. We're seeing this shift from, use LLM for everything, realizing that LLM has some limitations, right? And some weaknesses. But I think those are weaknesses and limitations that databases can really help mitigate. They're not going to completely solve them, but they can help mitigate that, because we have lots of good data in our data structures already. And so pairing the two, I think, together, this is where you see that retrieval augmented generation, or RAG concept. Pairing the database with an LLM, I think, is going to continue to improve that story together.
True. You said how to use it best, or where to use it. I mean, right now there's this meme going around like, I want my LLM to do my dishes, and I don't know whatever. Well, so it was differently. I don't want my my AI to do art and whatever. I wanted to do it the dishes.
Yep.
So I can do the art.
I want to mitigate the low, or delegate the low impact things to the LLM.
Exactly.
Yeah.
I don't, unfortunately, I can't remember exactly what it was right now. But if I find it, I'll put it in a show note. I read that. I was like, yes, that is exactly it. Why do we give the complicated tasks, or the stuff that we love to do, to an AI, instead of trying to offload the stuff we really don't like?
Yeah.
A good example of that would probably be writing the initial documentation for stuff. Looking at the source code, at the comments, and coming up with an initial draft for the documentation of that, whatever. Yeah. I mean, most of us are engineers, and engineers love one thing, which is writing code, but they hate the other thing, which is, hate the other thing, which is documentation.
Yep.
Right? So maybe that is something where we should look into and figure out if maybe it helps us that way.
Yeah.
All right. Cool. Yeah. That was a pleasure. Thank you very much for being
thank
here.
you so much for having me.
My
Always
pleasure.
nice.
Yes, and for the audience, Jennifer prepared a demo, which unfortunately doesn't work for an audio podcast, but we'll put it in the show note. And it will show you exactly like you can set up Neo4j on Kubernetes yourself. And we may actually do a recording, so I can put that as well. We'll see. Maybe not yet. Maybe somewhere in the near future.
Sounds like a plan.
Yeah, I know. Sometimes I have plans. Not a lot of times, but sometimes.
Whether they actually get implemented, who knows?
Exactly. You can always have good ideas.
Yep.
And there's plenty of those. Not all of them are getting implemented. All right. Yeah. As I said, thank you very much. It was a pleasure. It was good to talk to you after 3 years again.
Yeah, something like
time,
that.
Yeah, time just flies.
Hopefully we'll connect in person at a conference sometime in the future again.
I hope so. I mean, there is a lot of database conferences, a lot of Java conferences, so there's a good chance, I guess.
Yeah.
All right, and for the audience, thank you very much for being here again. See you all next week with the next episode and the next guest. Thank you very much for being here.
Thanks.